So the Chapter 11 quiz, there are a couple questions that might be a little confusing, so I was going to walk through some things on those. The first one is consider the following measures based on independently drawn samples from normally distributed populations. Two samples, we have the sample variances for each and the sample size for each. Then ask you to construct a 95% interval estimate of the ratio of the population variances. The book doesn't really get into this. The book mostly talks about hypothesis testing. But I have put on Blackboard, under weekly materials, week 4 materials, chapter 11, ratio of variances, CI for confidence interval. It's an Excel spreadsheet. So if I go to that Excel spreadsheet, I give you how you can calculate it by hand. Right here is the formula. And then I go ahead and do it and get the interval here for you. If we hit this, we can see how I'm getting it. I'm taking this basic ratio of the variances, sample variances, and I'm multiplying it times the appropriate F value from the F table. I'm using the functions that come with Excel, so F inverse right for right tail, and then that's this first one is the inverse of that, so 1 over that, and then the second one is just the F inverse right tail, and the probability, and then the correct degrees of freedom. So that's one way you can do it. The other way you can do this is to go into Minitab and go to Stat, Basic Statistics, and then two variances. And then we have sample variances, is the last option. Sample size for the first was 20. How big was it? 220 was the variance, sample variance. 15 and 196 for the sample variance for the second. Options, 95%. Standard deviation of 1 over the other one is fine. We could do that for variances, variance 1 over variance 2, click OK, click OK, and we get some output here. Tells us what we were trying to do, shows what the standard deviation is for each one of those, shows the ratio of the standard deviation. So here's the ratio of the variances, is what we're interested in. That's what I got back in Excel right here, 1.122. And then the confidence intervals for the ratio is what we're looking at, 0.392 and up to 2.97, which is exactly what I got using Excel. So that's the first question. The second question that you might get a little confused on, there's two that are similar to this. You might get one of them or you might get both. It is use the F table to approximate the probability that the F with 10 degrees of freedom in the numerator, 8 in the denominator, is less than 0.42. If we go to that spreadsheet and go to the second worksheet called FDist, I put in X, degrees of freedom 1 for the numerator, degrees of freedom 2 for the denominator, and in order to get this, I see that it's approximately 0.10 to 0.09. So if I look at the formula here, it's f.dist. A2 is the x. It's asking for what that value is. Degrees of freedom for the first, for the numerator, for the denominator, and then true for cumulative. If you get the other one, you're going to have to do a right-tailed because it asks for greater than or equal to. But this one asked for less than or equal to, that's why I used the true. If you get the other one, you can do the right-tailed, the fdist.rt, and get the correct one as well. So those are the two questions that hopefully will help you with the quiz from Chapter 11.